Hello everyone, and welcome to Greener Power Solutions' second webinar, Hybrid Solutions. My name's Andy Parker, and I'll be your host today. We're pleased to have you with us as we explore how battery technology is reshaping temporary power solutions, not just here in the UK, but also across Europe. And joining me today is our UK manager, Dan Pratt, and one of our battery specialists, Scheick. Now, whether you're tuning in from the construction, events, energy, or infrastructure sector, this session is designed to show you how hybrid battery solutions can cut emissions, lower cost, and improve operational flexibility. Now, before we dive in, I just want to quickly run through what we'll be covering today. We'll be discussing how hybrid energy solutions work and why they can bridge the gap between traditional and renewable energy sources. We'll also be discussing the role of Greener's mobile batteries in reducing emissions and optimizing energy cost in hybrid setups. I will also be discussing how Greener's EMS, or energy management system, ensures maximum efficiency and reliability for a hybrid solution. And at the end, we'll be going through a Q&A. So please ask questions in the chat during the sessions, and we'll cover them at the end. So over the next 30 minutes, we'll provide a refresher on basics of battery technology and why it plays such a key role in cleaner, more flexible energy systems. We'll also look at our in-house developed EMS, or energy management system. We'll also go through 3 case studies from across Europe, showing you how hybrid battery solutions are being used in practice for grid support and events. And as always, we encourage your questions throughout, so use the chat function, as one of our experts will be on hand to respond as we go. Now, we've also collected some questions from people when they signed up for this webinar, so we'll save some of them towards the end during our live Q&A. So let's start by setting the stage with a quick introduction. So who we are. Greener Power Solutions was founded in the Netherlands with a clear mission, and that was to accelerate the transition to a cleaner, more flexible energy future. And it started with a challenge. How do we reduce the reliance on diesel generators? The answer was mobile battery technology. And in 2018, Greener was born. And since then, we've grown from a small Dutch startup into a major provider with a fleet of over 185 battery units. And we supply clean energy to a wide range of sectors, including construction, events, grid support, and EV charging across the UK, Netherlands, and beyond. Now, what sets us apart isn't just the hardware. It's our energy management system. Now, this was built in-house to optimize energy use in real time. And that means lower emissions, better performance, and smarter integration with renewable energy sources. Now, across Europe, the energy landscape is evolving fast, but we face many challenges. Grid congestion. Many projects face delays due to limited grid capacity on site and long wait times for upgrades or initial connection. Diesel dependence. Now, despite growing pressure to decarbonise, diesel generators are still widely used for temporary power. And rising energy costs. Volatile energy prices mean businesses are looking for stable, affordable alternatives. Plus, we're all under sustainability pressures from governments, clients, communities. They expect more sustainable practices, and quickly. Now, these challenges are shared across the UK and EU, and that's where hybrid solutions come in. Our mobile battery solutions are already making a huge impact throughout the UK and Europe. On construction sites, we're helping reduce diesel uses by up to 80% while ensuring uninterrupted power supply. Festivals and outdoor events get clean, quiet energy without compromising performance. And also grid support. Our batteries enable projects to begin even when grid access is delayed, acting as a smart bridge. And EV charging. We're helping roll out our fast charging infrastructure by supporting the grid where capacity can't yet reach. The journey to net zero demands innovation. Battery technology continues to evolve with greater capacity, longer lifespan, and smarter control systems. At Greener Power Solutions, we're proud to be at the forefront of that shift, offering clean, flexible solutions that are scalable and reliable across the UK and Europe. And with our support, your businesses can move quickly towards emission-free operations without waiting for the grid to catch up. Now I'll hand you over to Robin, our systems specialist, who walk you through essentials of battery technology and our EMS.
Thank you very much, Andy. I am Robin, one of the systems specialists at Greener. I'm going to tell you a little bit about the battery components which we use in our EMS systems. So we have OEM-built 10-foot batteries container system, which comprises of a very nice branding and the innards, which are basically a main bus, which has a in, out and parallel ESI connected to it. So this input is 250 kilowatts.
So ESI is an energy storage inverter?
Yes, so that would be the entire thing of the batteries and the inverter together. So we have an input which is 250 kilowatts, 400 amps. So that's a single set of power locks. And we push them through to the output, and then on the parallel there is the inverter, which is also rated at the same 250 kilowatts, 400 amps. So that means that on the output we have the double capacity available. So that's 500 kilowatts, 800 amps.
Anywhere from 20 amps up to 400 amps across the input side.
Yeah.
And then the inverter joins that circuit in parallel, providing an additional 400 amps or 250 kilowatts.
Until the batteries are depleted.
So 500 kilowatt potential output.
Yeah.
At any time, whilst there's energy left in the battery.
And that always comes back down to energy balance within the system. Obviously, when the batteries have been, when you've been running that for a significant amount of time, there will be less energy available. One of the other key factors that we have in our battery systems is this transformer in the middle, which has 3 legs, 1 leg connecting to the input, a leg connecting to the inverter, and a leg connecting to the output. The two the 2 legs connected to respectively the input and the inverter are 315 kVA, and the output is obviously double that at nearly 650 kVA, slightly over, just to handle a bit more peak power.
Yep.
So we can stack the input we can stack the inverter power, as you just mentioned, on top of the input.
So you can stack the inverter power to the input, but we can also parallel the batteries together.
Yeah, and then we'll use only the input connection because there's a synchromatic switch there. So that means that if you're doing a parallel setup, because the batteries are 250 kilowatts, 400 amps, which only which happens to be the exact number that you can pull over a single set of power lock. So that's why that is a very logical capacity
for the temporary applications. That makes complete sense. Yeah,
complete sense. So if you need more, you either serial or parallel them next to each other to increase power and capacity.
How many batteries have we paralleled together in the past?
Well, I've just been told by the English country manager that we have had 10 in Rome for the Formula E.
Yeah,
just 2 years ago.
Yes,
even more, something like that. About 2 years ago.
So that's 10 batteries in parallel. So that's 2.5 megawatts of inverter power alone.
Yeah, 3.5 kilowatt hours of capacity and 2.5 megawatts of brute power.
So how much energy storage is in each of the containers?
Right. So we have a 336 variation and a 422, and that means that it's basically the inverter side. So that's the power side. All of this is exactly the same. The only thing is that on the battery rack there is space for 10 BMW i3 batteries.
So they're electric vehicle batteries.
Electric vehicle batteries. So it's a BMW without the crappy part, and then the useful part left, which is the battery.
Yeah.
And then we have a 8 stack version and a 10 stack version, which then gives you the capacity difference. And then the individual packs are about 42 kilowatts hours.
And energy density is improving all the time. I'm aware that the new systems that are coming into our fleet are considerably larger, some of them.
Yeah, the capacity in each pack is.
So for a 10-foot container, I believe we're getting up to around 700 kilowatt hours of stored energy in a 10-foot shipping container.
In a 10-foot shipping container. And then still and that's only really changing the battery rack side. and then the electronic side is staying more or less the same, because it's logical to keep the single single power lock system is a very logical sizing. And then when you've got all of this very nice OEM hardware, it actually needs to be controlled. So we have a Greener Eye, which holds our EMS system, which is a bit of software that we write ourselves and control ourselves. And then with that, we control all the bits and pieces, read and write all the bits and pieces which are in the battery system. Amongst others, the inputs and the outputs are completely measured out, so we know exactly the amount of power that's flowing over the single phases and over the total, which of course you need these numbers in order to do energy balance,
to calculate what the inverter needs to do.
Yeah. If you don't know if you've not measured anything, you can't make any switching decisions. So our EMS gathers all these things and controls all these things and pushes that to our to a database in the cloud. And then from that database, we have our own in-house Greener Projects, which is a portal on the web. And you can visualize or enter the portal from any browser.
So anyone we wanted to give an account to log in to view their data, we can easily do.
Exactly.
So any one of our assets that is up and running is automatically pushing data to the cloud and is displayed within Greener Projects.
Yeah, and then the project owner gets login, and then they can disperse that as they see fit
to other people within the organization that are interested.
Whoever needs it or is interested.
Yeah.
And then some of the stuff that we can do with that, of course, is some of the applications are the ones that we see on the screen now. Zero emissions. You can imagine that if you have a small grid instead of a large generator, which we will get into later. Quiet nights. If you have a generator standing there, but you want it to be quiet during the night, we start it a little early, make sure that the battery is charged at a specific point in time, which is dependent on the project.
So that would guarantee enough energy in the battery to get you through the night based on some load information that we need to calculate.
It'll guarantee that it's full at the moment that the night shift starts.
Yeah. But then it's down to how much energy is being consumed over the night, which will dictate whether there is enough energy to get through till the following morning.
Yeah, and then we can see by the data gathered if that is or isn't enough, and then we can take appropriate measures.
Through the analytics on Greener Projects, that might be an additional battery to give the required energy storage.
Could be all sorts of things.
Yeah.
But more batteries are always a good idea. Right. So, and then when we have all of these things, we can then make these kind of setups. So we can integrate solar, wind turbines, any kind of renewable onto our microgrid next to normal grid and generators. And then for us, whatever you're powering is whatever you're powering. So that could be anything. Mainly construction and events at the moment. And in the UK, I believe we're doing quite a lot of EV charging hubs as well.
Yes, we have done some EV projects in the past. Yeah.
Right. So enough about the potentials, and now some of the real life usages, and that's over to you, Dan.
Thanks, Robin. So hi everyone. I'm Dan. I'm the UK manager for Greener Power Solutions. So I wanted to look at a recent case that we just completed, a project that we finished. And we were tasked with powering some MRI and CT scanners for a hospital. So, of course, these bits of equipment require very large impact or inrush currents to start the scanning process. So this isn't dissimilar to a crane or an electric vehicle charger. Of course, that's a lot of power when the car's charging, but then when the charge is finished, it's no power.
None at all.
So these scanners are quite similar. Big impact roads, tower cranes are the same. Any big motorized loads, such as hoists on a construction site, etc., all have these sort of transient moving loads that really make battery systems come into their own.
Yeah, old school triangle and startups.
Star Delta Motors, 100%. So we were approached with a problem. So the initial setup on site was one individual scanner. Now on the technical sheet for the scanner, it suggested that the inrush currents could be around 300 amps. So a 300 kVA diesel generator was specified to power the scanner. But there was also a 63 amp three-phase grid connection on the site, which you can see here. But initially, that wasn't being used because the load required by the scanner, 300 amps, 63 amps, we're never going to get anywhere near it. So initially, that was what was done. So Greener came in and we installed a battery system to hybridize that existing 300 kVA diesel generator. At the same time, a second scanner. So we now had 2 loads with potentials of up to 300 amp inrush currents. But by hybridizing the generator with a battery, we were able to provide the potential of 600 amps by utilizing the generator and battery together. Because, of course, we've got a battery capable of doing 400 amps and now a diesel generator that's capable of doing 350, 400 amps itself. So they had sufficient power available to drive the scanners, but also through the installation of the battery, we start collecting data. So all that data is being pushed up to the cloud and then displayed in Greener projects, as Robin was saying. So you can see the example load profile there. We'll go into a bit more detail on that shortly. But through this data, we were able to understand that the 63 amp 3-phase power supply was actually sufficient to provide the energy required to run both scanners. So what did this mean? It meant that we could physically turn that generator off and remove it from site altogether, knowing that the 63 amp was sufficient to provide the energy, whilst the battery was still sufficient by itself to drive 2 scanners simultaneously. Yeah. So this ended up resulting in the generator being removed from the site.
Yeah, because the 63 amp connection will provide in a course of 24 hours over a megawatt hour of energy. So that's nearly 3 cycles of a battery.
So 3 charge cycles of a battery.
3 charge cycles of a battery.
Yeah,
just out of the wall.
It's often misunderstood quite how much physical energy you can harness from a very small grid connection, which again, most people just disregard these small grid connections because they think my load requires this, that's not going to do it. But by utilising the battery system, it really shows what you can do to drive these large bits of kit from very small power supplies. So that would be what we call peak shaving. So we have a small power grid connection coming in, and then we, again, as Robin explained, stacking the inverter on top of or in parallel with that, which then means we have the peak power available to come in. Also through the data gathered, you can see here, this was a week's worth of data from both scanners running simultaneously. And although it is exceeding the 63 amp mark, it never goes anywhere near the potential 600 that we were initially tasked with.
Yeah, you can see here that the load in the downside is 30 amps, and then on the
so the daytime operation
goes over 90.
Over 100 odd amps there. But because that nighttime load is 30, whatever energy was used from the battery to drive the scanners during the day, of course, whilst the load is over that 63 amp mark, the battery is depleting. But because the nighttime base load set at 30, we had the remaining 33 amps to charge. Exact, to recharge the battery so that the battery was fully charged for the following day. So really the results were that we started with the hybrid solution, gathered the data, and from the initial setup, just by hybridizing the generator, still leaving the generator as the charging source for the battery, we reduced the generator run hours by 87%, which resulted in a 56% fuel reduction and a obviously related emission reduction on site. And then eventually we moved to the peak shaving setup, which eradicated the requirement for any diesel to be used on the site whatsoever.
And every litre diesel is what? £1.50 nowadays? What is it?
Yeah, something like that. It changes. Yeah. So that concludes the first case. I'll hand over to Robin
for
our second.
So this is a theatre festival in the middle of Den Bosch, which is a city in the south of Holland. They had a week long of little pop-up theatre shows and a central area, which is a big field, where they were doing all sorts of more elaborate theatre shows. And they were running this for a couple of years with a tandem setup of 4 500 kVA generators.
So 2 megawatts of power.
2 megawatts of power.
2,000 kVA.
Potentially, yeah. And we ended up placing 2 batteries in the first year and 4 batteries in the third year, and a very nice resolution in the end. And that, of course, then reduced the usage of diesel and running hours on these generators significantly.
So the noise on site's reduced.
Oh yeah, fantastic. I mean, it's really nice if you're sitting in the audience and you hear the hum of the generator in the background in the silent place.
Smoke pouring over. Yeah.
Lovely. So on the first, when we came into play, we had a setup that looks very much like this. There's a central farm 4 generators into a point of coupling or a bus, and then a ring or half a ring really, one going left and one going right. Two circuits being fed off this one central point. We also there was mention of a grid available somewhere. So we did a little bit more digging into the grid that would be available, and we figured out that there was a 315 amp grid available. So we measured the grid coming in, made 2 separate circuits. So those 2 separate circuits that were already there, we connected to a individual battery, placed 2 batteries, and made sure that the 2 batteries among themselves disperse the available grid equally.
You're not just splitting that 300 amp supply in
50-50, no.
You're giving the full amount in both directions, but measuring it, and then allowing Greener's EMS to decide which side needs the most at any specific time.
So you can imagine if one of them has a food court, then for those the moments that the food court is actually being used, so that's like between 3 and 7, when all the cooking equipment is on, the load will be very, very high
on one side.
On that one side,
not necessarily as high on the other.
No. So then more energy can be pushed towards that side of the grid, as opposed to the other. We did place 2 generators on. So on each circuit there was a backup generator. I believe in that week they ran 2 or 3 hours at most.
So they were installed just in case the total load was exceeding the supply and we were going to run out of energy at some point. So they were there as for resilience as well.
Or the grid failed.
But they did need to run because the site was consuming more energy over time. So they were needed for that setup.
For a very, very small amount of time. They only ran 2 or 3 hours.
But that data you're able to gather through
our EMS.
Through our EMS.
Yeah. And then the year after, we thought, well, if we do a little bit of thinking and a little bit of reduction in the load, and that a reduction in load doesn't mean not doing things, but switching things on at a different time.
Changing the culture on site is a big part of any energy management.
Yeah. So, for instance, if you have a big coolant container,
a big
with drinks in, big fridge, and then I mean the 20-foot container kind of fridge, you don't need to run that 24/7. You could, in a high demand period, switch that off
as long
for
as
a couple of
people
hours.
Aren't leaving the doors open during the middle of the summer.
Obviously, in a 40 degree field, maybe close the door.
Yeah.
So we doubled the capacity by putting a second serial battery in there.
So now effectively for each leg you had 840 kilowatts of
kilowatt hours of capacity available. Yeah, and we completed and we did the entire show there. And then the year after, they got a 400 amp grid in, and that was enough to just run the entire show directly off grid with no extra equipment required.
So, although it's a bit of a shame for Greener,
wow,
it was a great result for the customer through the data gathered through our EMS, because it gave them the ability to push that grid connection from 315 up to what they required to do the whole show without
400. Yeah, exactly. Yeah. And that's a really nice adventure for everybody. So we did bridge the gap. We were able to help them bridging the time or the gap between the deliverance of the extra power from the grid, and by using a hybridized approach, we could utilize the grid fully until the capacity of the batteries was depleted, and then for the year after we could put in more capacity. And then
if the customer did want some resilience on site still, because of course how they're running now is the 400 amp connection supplying everything, there is no resilience or backup in there. However, if they did want that,
we can put it all back
again.
Batteries
back in again. Yeah.
So that's all going to costs and savings, right?
Of course.
Which of course is what we try to endeavour. Then we have one more case to discuss.
Yeah, thanks, Robin. I'll take this one back. So this was a grid delay to an aggregate processing plant that we were approached to help with. So they were waiting for an 800 kVA grid connection to come in. It was a relatively new aggregate processing plant, so they require huge amounts of power. And it was a 24/7 hour operation, so constant energy demand. On this specific site, they had a 350 kilowatt peak solar array installed on the plant's roof that they were unable to utilize because they were running the site from two 500 kVA diesel generators. Now, they couldn't turn that solar array on whilst being run by the two diesel engines. The reason being, if the solar array is pushing more power than the site load's consuming, then there's nowhere left for that excess energy to go. The only way it could go would be back to the generators, which would cause the alternators to overheat. And of course, most generators do have a protection function that would cause them to shut down if they detect power is being fed back in, because eventually that alternator would melt, catch fire, and explode.
It's designed to produce power, not absorb.
Absolutely. So what did we need to help here? It was batteries, but you can see from the drawing here, they're waiting for the 800 kVA grid connection. Solar array not in use, the site being powered by the two 500 kVA generators. So our solution was to install 2 greener batteries that were sufficient to power the entire load by themselves standalone. So we put them in parallel, formed our own microgrid on the site. And this enabled us to switch the solar array on. Mm-hmm. The reason being, we now have somewhere for any excess energy that's not being consumed by the load to go, and that is into the batteries to recharge them.
And we also managed to control the solar array and reduce the amount of power produced by the solar when the batteries are full.
Yes. Yeah, if the battery was becoming fully charged or was reading 90%, then Greener's EMS was curtailing that solar array, just turning the power production back so to avoid overloading overcharging the batteries, which would initiate a shutdown on the batteries, because similar reasons for the generators, there's nowhere for that energy to go.
Yeah. And it'll curtail it by percentages.
Yes.
So up and down, minus and plus 1. So that means the system tries to match the power production to the power needed after the batteries are full.
So it's making the full usage of that solar array on the site. Of course, it does get dark at night, so we still needed an additional energy source to help the plant for their 24-hour operation. Of course, when the solar's not producing, the batteries would eventually deplete and we'd run out of energy. So 2 generators were still utilised, but they were only utilised overnight, and we were still able to downsize those generators from 2 500 kVAs down to 2 300 kVAs, that only one of which was required to run to support the site load, because the batteries inverters were dealing with all of the main load. Mm-hmm. And of course, the other generator was there for resilience. Should generator 1 fail, generator 2 could start and take over the job that generator 1 was doing.
And these were in a rotating scheme in fixed power, so the batteries would ask for energy from these machines when they've depleted.
Yeah, so you can see here, all the power assets are connected to the bus. So the 2 batteries, the 2 generators, and the solar are all connected to a common point. The generator controllers are programmed in fixed export. So when they are told to start by Greener's EMS, which can be just a simple I/O, the start relay, or we could control the export level over Modbus control, again, depending on what generator controllers are being used. We can then start the generator, it will synchronize to the bus, and then the power export level can be moved over Modbus by Greener's EMS on a sliding scale, in the same way we can control the solar.
Yeah, and then of course the name of the game is to get as much kilowatt hours out of a litre diesel as we can. So we run them at 80%
optimum
capacity,
efficiency,
something like that, and then switch them off when they're not needed.
Yeah, and this setup, you could also utilise a smaller amount of grid connection. So if they didn't have, obviously they don't have their 800 kVA connection in, but if there was, for instance, a 100 amp grid connection even, you could still connect this to the common bus through some of our grid sync technology, which would enable us to force charge the systems through that device as well, or a wind turbine, but mobile wind turbines are getting there, but still not quite readily available in the market.
Well, we know of one.
Yeah. So that was that project. Of course, when the grid connection comes in, we'll be surplus to requirements. Unless their production oversteps the 800 kVA mark, then we can come back in and help support with a grid boost solution. Yeah. I think we can discuss in a future webinar.
Exactly. Trading on the web.
Yes. So the results were we bridged the gap for the customer whilst they were waiting for their grid connection to come in. We were able to utilise the solar through microgrid integration, downsize the generators, which dramatically reduced fuel costs for the customer on site, and everything being controlled via our Greener EMS.
Mm-hmm. And we're going back there this year again, right? Because the grid is still not there.
The grid is still not there. No, exactly that.
Thank you very much.
Back to you, Andy.
I'm sure that was, thanks, Robin, Dan. That was really insightful. some useful live cases there, which I'm sure some of people watching can relate to. And that brings us to our Q&A session. Now, we've collected some really good questions from the chat, so let's get into them. I think if I can, Dan, we've got quite a few coming through now. Again, we've just touched on solar there, Dan. We've got one of the delegates asking, have a site where I need to curtail my solar array. What can Greener do to help? So how can you kind of help the client? I think you kind of touched on it with your explanation a minute ago, but specifically to that question, how can that client potentially curtail their solar array?
So, yeah, there is a need to curtail. So that's due to distribution network operators stipulating that you can't export to the grid at certain points of time. So obviously the site before, we weren't talking about a grid-connected solution. It was a microgrid battery-driven solution. Yeah. But any industrial site that has solar installed and they don't have a grid connection that has an export arrangement that they can utilize, we could install battery systems into that network that would enable us to make the most of that solar production, store it in the battery so they could then utilize it when the solar stopped producing to power the site.
Yeah.
So I think some people refer to it as solar sponging, but that's effectively what you're doing. You're putting a buffer in place, being the battery, to make use of the solar, meaning that you're not having to turn it back, and you're not having to waste any of your on-site produced energy by throwing it away or turning it off.
And I guess the same would apply to the larger wind farms that you see.
Potentially, No, anything with an export restriction, batteries can really help manage that on site.
And it's also, of course, a bit of a weird idea that you switch your own production off during the day and then buy energy from the grid at night.
At night, Why not store it somewhere?
Store it and
use
then
it for yourself.
Yeah, exactly. Yeah. We've also had it's a good response there, gents. We've also had another question come through. Do we need to let the main supplier know what we're doing in these scenarios? So do you have to let your energy provider know, or what's the general kind of rule of thumb?
So G99 and G100 are the regulations in the UK that you'd have to look at. So that would be the same as installing a solar inverter on your house.
Right.
It's notifiable to the DSO.
Okay. And what if it's for self-consumption? So you've got a large kind of building with solar on, and you're going to consume that energy back into your own building, for example. Do you still have to let the provider know?
So for direct connection to the grid, yes, they'll be looking at what size inverter are you connecting to your connection point.
Gotcha.
And if that has the potential to exceed the connection point, for instance, if you had a 200 kVA connection and you wanted to install a Greener battery with an inverter rated at 250 kVA, they're going to be asking some questions, because there's every potential to backfeed that additional 50 kilowatts to the grid. But that all depends on the setup. So more permanent solutions, that would be worth running through. We can also isolate from the grid and run a separate microgrid the other side of the site, which might be an option for some customers to consider, because then you don't have those limitations, because your connected inverters are equal to or less than the supply intake. But you can microgrid as big as you want the other side, as long as there's some separation between.
Yeah. And we'll get into how microgrids actually work in large scale, I guess, in the next one.
Yeah. No. Again, while we're on the kind of the renewables kind of vibe, we've had one of the people ask a question: do we have to use all of the available grid? So, if you're kind of taking power from the grid into the battery, have you got to use all of it, or can you manage it? I think you touched on it before.
So we there's a couple of ways you can do it. You can put the batteries in parallel mode. Then we put a meter on the grid, and then per project, it will be defined at the front what the limits are on that meter. So if the project tells us, well, we can have a limit, a maximum limit of X and a minimum limit of Y, which could be positive or negative, that's the bandwidth that we'll use. Right. We had a project the other week in which there was a 0 positive maximum and a negative infinity, and then there's often the other way around as well. You can take some, and then maybe the load exceeds that. So let's say that there's a negative 0, so you're not allowed to backfeed at all, and you've got 100 available on that point of measurement. Yeah. But the load goes to 300, then we'll hold that 100 on the grid.
Ah, okay, right.
And it doesn't. And even if you've got it's all about what am I allowed to do at the point of coupling.
Well, I think
Wherever that is.
No, exactly. It's a great response. We've had another question, again relating to this, and this individual's asked: do we have to submit an application when we're connecting our battery to the grid, to the DNO or the DSO or the equivalent party? Do we have to tell them that we're connecting?
So yeah, that's very similar to the question we answered first up. It's the short answer is yes.
Right. Perfect.
Yeah.
Good stuff.
It's interesting how that differs from location in the world.
I think because we're dealing with batteries across Europe now and the UK, so regulatory constraints can obviously differ, can't they?
And
So
it depends on what mode you're utilising the battery for. If if you're using the battery in peak shave mode, there is no physical way of the battery pushing power back to the grid. The battery in that instance is nothing more than a load on site. So if you're running a factory, you don't notify when you plug in a new motor.
No.
Yeah.
We're just consuming energy from the grid. We're not trying to push any energy back.
Yeah.
So in that instance, in peak shave mode, you're really quite safe to connect and utilise.
Perfect. Okay, we've got another one here. Do we have products in the USA?
Again, short answer,
no.
Not yet.
Not yet.
We are looking at considering it, but currently now we're focused on Europe.
Okay.
And expansion through Europe.
Okay.
Yeah, we will do the 60 hertz network. We can switch that back and forth.
Yeah.
So that would also for marine applications on boats and whatever not. We need 60 hertz systems. That's fine.
Super. We've got another one here. There's quite a few to get through, but I'll just pick this. Oh, there's a good one. How do you calculate the return on investment? Dan, I'll put on that one to you.
So the return on investment would be more applicable to anyone that was looking to purchase a battery asset for their installation. However, we do often look at this. We're having to build business cases for customers that say, I'm currently running diesel generators on site. I'm interested in renting a battery, but tell me what that's going to do. What does that mean for me? How does the rental cost of the battery get offset? And the way that's offset is through fuel reduction. Yeah, plain and simple. And that's what we're able to calculate with our microgrid builder software. We can enter the specifics, the details from the site, so what the load is, what the energy sources are, what size battery we're proposing to put in, and our software would crunch all those numbers and calculate what the expected savings are likely to be on the site. And if that expected saving of fuel reduction equates to the cost of renting the battery, then surely you're onto a winner there, because there's not just the costs to consider, there's also the environmental impacts of the CO2 reduction and the noise pollution.
Yeah. And another thing to consider, if you're a energy rental company, so you're renting out generators, we will significantly reduce running time of these generators, and will significantly increase the load on the generators. So that means that the health of the generator will stay a lot better.
And the longevity.
Longevity, because we will not underload these generators, and because you're reducing the running hours, you don't need to visit them as often either. Yeah. So if you're going from a 24/7 to a 24-hour run in a week, you can imagine that you can extend your visit to the generator for maintenance by 6 weeks.
Yeah, most generator companies would be servicing their engines in the field every 500 hours. Right. But of course, as we said earlier, the majority of the hybridization projects we do, we're reducing generator runtime by 80%.
Exactly.
So that's 80% less visits to site to service the machine. It's 80% less hours that machine's going to clock up over time. So it can really reduce the operating costs for any diesel generator company to start offering battery solutions as part of their overall offering as well.
Okay, we've got time for perhaps maybe two more questions. Going back to a battery connected to the grid. So if we've got a grid supply, when a battery is connected to the grid and the grid supply drops out, does the battery system need to trip, or can it maintain supply under a secondary earth point, which include a backup generator?
You want to take that one?
So it depends on how if you're doing a serial setup, so the load is on the output of the battery, then we will have a backup functionality within the battery. So if the grid falls away for whichever reason, you'll have a 4 microsecond dip. So that's not good enough for a UPS. So that's why we never say it's a UPS.
Technically sellable as UPS.
No, but it does have the backup functionality. The light won't. If you have an incandescent light bulb, you won't see it flicker.
And that's the battery going from what would be grid following when it's grid connected
to forming,
to immediately flip into grid forming. And that happens in how long?
4 microseconds.
4 microseconds. So
super fast.
No real electrical equipment is going to notice.
And we're talking about the very complicated bit of electronics, which is the CT scanners.
Yeah.
They never noticed when
we're moving
when
from
we're switching up back and forth, because that's basically what happens when you're doing a cycle. As soon as you've fully charged the generator and you switch it off, you're going from following the generator on the input to
grid forming battery mode.
Okay, and there's one. There must be a few diesel generator rental companies listening. One final question here: if a generator hire company makes money from selling fuel, how do you overcome the loss of that revenue stream, Dan? I think,
it's a difficult one
coming from that sector.
Of course, I mean, do you really want to still be profiteering off selling diesel fuel? Would be my first question. But how do you overcome the loss of that? So we have framework contracts in place with the majority of the rehire partners that we're working with today, and the way we've got those framework agreements set out means that if we basically mean that we can allow that generator company to make enough margin on the upsell of the battery to cover any loss of revenue that they might be missing out on through the fuel consumption.
So the offset, basically.
Usually through most of the partners we've been working with, they are making more money through adding value than they are currently making. The margin on fuel is very small. So for a litre bought, you can't be selling it at 20% higher than that. But there is a better margin to be made on the battery rental side.
And a very significant and it's not only the fuel, but also the reduction in costs, which is also a thing. Because you're running a lot less hours, you need to visit the machine a lot less. So that means a guy not needing to go there with a van full of stuff.
So there's that cost to take into account.
Absolutely.
Well. Brilliant. Well, I think we've got through quite a few questions there, and hopefully it's helped everybody out there. So thanks again for all your questions. If you've got any further questions, please feel free to reach out after this session to either Dan, Robin or myself, and we'll do our damnedest to answer those. And unfortunately, that brings us to the end of today's session, and thanks again for joining. We've got more webinars lined up for the autumn, where we'll take a deeper dive into the technical side of temporary battery storage systems and more detail around our EMS. In the meantime, we'd love for you to stay connected by signing up for our newsletter. Just scan the QR code that's on the screen now for updates on upcoming webinars and industry news and insights from the Greener team. Thanks again for spending your time with us, and we look forward to seeing you at the next one. Thank you. Bye-bye.